Now recording. All right, so let me start to share the screen. You can turn your cameras off if you wish, but not tomorrow. So next 5 minutes or so, I'll blab once again about my rules and regulations. Okay, so tomorrow is our first test. As you can see here, no questions and answers tomorrow. The entire time will be the test. So any questions, it has to be today. And you also submit the homework. By the way, you can submit the homework right after class. I'll take it anytime now until half an hour after the exam. Okay, I do have the 70% requirement for homework, which means if you don't turn in at least 70% of all of this, I don't grade your tests. It will not count. It doesn't matter if you get it perfect, I'm not going to count it. Okay, it's not that hard to get 70%. After all, I end up doing what, 50%, 40%, 60%. So it's not really that hard. Okay, I'm not sure this can all fit in one email. So if we want to break it up into 5 emails, one from 1.1, one from 1.2, and so on, or maybe one email from 1.1 to 1.3 and 1.4 to 1.5, that'll work. I'm using a school computer. It's not the best. I'm not sure I can get zip files. If you send me a zip, I've had experiences in the past where I can't get a zip. So maybe avoid zip files, or nothing fancy. PDF, I'm pretty sure I can get. Okay, so now that you've submitted a couple of quizzes, you do the same thing for the homework. Just click, 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 and email it to me. Same email address. And then when you're done with the test, same thing. Click, 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 email it to me. Okay, and let's see. A little bit after 9, so maybe 9:01, 9:02, I will send you the test via Canvas announcements. So you can use it in Canvas announcements. If you want to print it out, you may. I will also, once we get started at 9:10ish or something like that, I'll project it here because some of you like that better to catch everybody. So I'll project it. You know how I sometimes on the quiz, I project it and actually take a picture on your cell phone. So I'll do that. But if you want to get it through Canvas announcements, that's great too. I'm trying to catch everybody. And yes, this is the one time I insist you have your full camera on and your natural background behind you. So no fake backgrounds, no Golden Gate Bridge, anything like that. I have to see your actual background so I can monitor there's no funny business going on. Now, if during the test, you know, you have to go get a drink of water, you need to go to the bathroom, let me know. So if you disappear and say, hey, where did Mary go? Where did John go? Are they going out and cheating, you know, whatever. So if you got to go to the bathroom, fine, just, you know, put it down in the chat that, you know, that's the reason why I'm not here. I'm not cheating. I'm just getting a drink of water or whatever. Okay, so have your actual camera on. And what else? You can have one formula sheet, one cheat sheet. Put anything you want, one sheet of paper, standard size, 8.5 by 11, double-sided. But beyond that, you're not supposed to use anything else. So you're not supposed to use other people, you're not supposed to use a computer, internet, books, notes, anything else except for your one cheat sheet, your one formula sheet. Okay, yes, you know, and I know, it's pretty easy to cheat now compared to when we were meeting face-to-face. Face-to-face, I can see if you have any device with you, you know, somebody's texting or whatever. Now you have to have a device, you have to have a computer, you know, that's obvious. So it's a lot easier to cheat, so-called. So, and that's one semi-safeguard. Of course, I can't catch all cheating, but, you know, that's why I have the homework rule. Okay, so I look at the homework, I look at the test. Hey, the writing doesn't match, right? Whoever wrote this homework isn't the same as the person who wrote the test. So I get very suspicious. And again, I already have a sample of your writing for your quizzes. Yeah, again, I'm not a handwriting expert, but, you know, I can tell, yeah, this person's writing doesn't match this writing for the quiz and the homework or the test. So I get very suspicious, right? Okay, again, part of the reason is, you know, a student might get somebody that wants to cheat for them in a test, but you're much, much less likely to find somebody who wants to do all this homework for you, right? So that's some procedural things about the test itself. During the test, so camera on, mute yourself. If you have a question during the test, send it through the chat. Do not unmute yourself and say, hey, I got a question on number 7 or whatever. Okay, again, think of the equivalence if we were meeting face-to-face, right? If we were meeting face-to-face and we had a question on the test, you wouldn't just yell out, hey, how do you do number 5? But, you know, you would come up to me or raise your hand and we would talk privately about that and not disturb everyone else. So same thing, if you have a question during the test, just send it through the chat and I'll reply during the chat. If you finish early, you may leave. Okay, so I will end the class at 10 o'clock as usual, but if you finish early, that's fine. And just take a picture on your cell phone, just like the quiz. Click, 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 click. And then so I'll give you 5 minutes after the end of class. So 10 o'clock, you have until 10:05 to submit the tests. And then I'll give you until 10:30 to submit your homework. But hey, after class, you already finished your homework. If you want to submit the homework anytime from after class today until 10:30 tomorrow, you may send the homework in. If you want to send the homework in early, that's fine. Now, I don't grade the homework per se. I don't look for correctness. I pretty much just look and see if you did it. Okay, and that's it. So homework doesn't count point-wise, but just think of it as a pass. It's your ticket. It's your ticket for me to grade your test. So no homework, no ticket, quote unquote. I don't grade your test. It counts as a 0. Okay. Right. So those are the main things I have about that. And yeah, let me check the chat one more time before I get. Let's see. Okay, 1.2, number 5, I think. Yeah, okay. All right, and thank you, Prasanna. So Prasanna can help you. Check Prasanna, just send something in the chat. So pen or pencil, I don't care. Pen or pencil is fine. All right, I see other things there. Okay. All right, so I'm gonna go ahead and get started. Continue putting stuff in the chat if you wish, and maybe Prasanna can catch some of them for me. But now let me go ahead with my review session now. Again, I only want to do problems that are right from the homework. So if you ask something that's not from the homework that doesn't relate, I don't think that would help too many people. So, okay, 1.1, number 35. (1.135). Find the domain of h of x equals 1 over the 4th root of x squared minus 5x. Find a domain, okay? So the thing behind my finger has to be greater than 0, not greater than or equal to. If I only saw this, it'd be greater than or equal to. You can take the 4th root of 0. But since it's in a denominator, I cannot allow this to be 0. So we can only take the 4th root of positive numbers in 0. So in this case, x squared minus 5x is strictly greater than 0. X times x minus 5 is greater than 0. Again, because of time, I will have to go somewhat fast. So in other words, I'm aiming for quantity more than quality, frankly. You can always check the video later for this. Okay, so my boundary numbers are x equals 0 and x equals 5. Okay, so the way you do this is put a 0, put a 5, open circle, open circle. If I plug in 0, it would say 0 is greater than 0. That's false. If I plug in 5, it will also say 0 is greater than 0. That's false. I have 3 regions, region 1, 2, and 3. Pick something here, here, and here, and I plug in. So region 1, 2, 3. So region 1 is like a -1. Region 2 is 1. Region 3 is 6. You can pick any number in a region. Okay, you could pick 7, 8, a million, but I'll pick 6. Okay, plug in and just give me the sign. -1 is negative. -1 minus 5 is negative. A negative times a negative is a positive. Is a positive greater than 0? Yes, that's true. So shade in region 1. Okay, plug in 1. 1 is positive. 1 minus 5 is negative. Positive times a negative is a negative. Negative greater than 0 is false. Do not shade that region in. 6 is positive. 6 minus 5 is positive. Positive times positive is positive. Positive greater than 0, that's true. So regions 1 and 3. So the domain is -infinity, 0, parentheses, union, 5, comma, infinity. Okay, this region, not counting the 0, not counting the 5. Okay. And then let's see, 49. Same section, sketch the graph of absolute value of x. Absolute value of x is less than or equal to 1. And 1, absolute value of x is greater than 1. Okay, another way of saying this is x lies between -1 and 1. Another way of saying this is x is less than -1 or x is greater than 1, which basically means everything else. Okay, now I know absolute value function is v-shaped. So there's my v-shape from -1 to 1. The rest of the time it's constantly 1. Y equals 1 is a horizontal line. So like that and like that, and that's the whole graph. Okay, so that's it for 49. Let me raise it up again so you can see this in case you want to catch the video later. Better focused. Okay, and then let's see, 57. 57, a rectangle has a perimeter of 20 meters. X and Y, perimeter is 20. Express the area as a function of the length of one of the sides. Okay, so let's see how to do that one. So the perimeter is 2L plus 2W. Okay, 2 times X plus Y. Divide both sides by 2. 10 equals X plus Y, or Y equals 10 minus X. All right, so now the area is X times Y, but Y is 10 minus X. So 10X minus X squared is an expression for the area in terms of one of the sides. Okay, so perimeter, 2L plus 2W, 2X plus 2Y, factor out to 2, divide by 2, and subtract, solve for Y, and then I put that in. Area is length times width, X times Y, so like that. Okay, and then let's see, 63 was asked for. Okay, so 63, they gave me this picture. You make a cutout like that. Okay, the whole thing here is 20. And this is 12. And all of these are X all the way through. Right, so find the volume. So you fold up the flaps. You lose an X here and an X here. So length times width times height. The new length is 20 minus 2X times 12 minus 2X times X. Length times width times height. The new length is 20 minus 2X. The new height, width is 12 minus 2X. And if you fold up these flaps, the height will be X. So that's an expression for the volume. Okay, so that is that. Let's see, 1.2. You can keep typing stuff in the chat if you wish. I'll get to it eventually. 1.2, number 5. Find the domain of the function. F of x equals cosine x over 1 minus sine x. Okay, so the only trouble is the denominator. Okay, we can take the cosine of any real number. So what about 1 minus sine x? So I solve 1 minus sine x equals 0. Throw that out of my domain. So sine x equals 1. So on my unit circle, sine of what angle is 1? Y coordinate is 1. That's up there. That's pi over 2. And then any multiple of 2 pi after that. So x is pi over 2 plus 2k pi, where k is an integer. Okay, so pi over 2, 2k pi. So if k is 1, that means I'm going around one more time. Plug in 2, you're going around again. Plug in -1, you're going around backwards, and so on. Okay, so I'm basically throwing this out. So the domain is all real numbers minus the set consisting of pi over 2 plus 2k pi, where k is an integer. Okay. Remember, anything that you might feel fuzzy about, you can put it on your formula sheet, put it on your cheat sheet. Okay, you're allowed to put sample questions and formulas and whatnot. Just one sheet of paper. That'll be fine. Okay, 7. Okay, so find equation family members slope 2. Okay, so 7a, it says slope is 2. That's basically y equals 2x plus b. Okay. So slope is 2. So the only thing that changes is the y-intercept. So draw several members of the family. Well, you know, very crudely, that's a slope of 2. And then I just draw a lot of lines that are parallel to that. Okay. So there we are. Part B, it says f of 2 equals 1. That means the line passes through 2, 1. So using the point slope form, y minus y1 equals m times x minus x1. Okay. So they all go through the point 2, 1, and you just change the slope. Now a little bit of algebra cleanup. Y equals mx minus 2m plus 1. Okay, I just distributed and added 1. So for this family, they all go through 2, 1. 1, 2, 1. So I just draw a whole bunch of lines that go through 2, 1. So it's like you just hold this down and spin around. It's like you just literally take a spinner and spin it all over the place. Right? And they all go through the same point. And finally, C, which function belongs to both families? So it has to satisfy A and B, i.e., it goes through this point and the slope is 2. So I just put a 2 there. So y minus 1 equals 2 times x minus 2. And clean that up. Y equals 2x, let's see, minus 4 plus 1, 2x minus 3, I believe. If I did that right? Yeah, I think that's it. Okay, and again, let me raise it up if you want to look at the video later. In case you can't see what I'm writing. Okay, so that was 7, and then 1.2, 17. Yeah. Okay, so we want t as a function of n. Okay, so that's normally y is a function of x. So my ordered pairs are t here and n here and t, right? So you have to make a substitution. Y is a function of x, t is a function of n. So that's why that's x. So the first case, the number was 113 and temperature is 70. And then the second case is 173 and 80. Okay, number of church per minute, temperature. So slope is 80 minus 70 over 173 minus 113, which is 10 over 60, which is 1/6. Throw it in the point slope. Y minus y1 equals 1/6. X minus 113. Change x and y to what they are. The x is n, and y is t. So t minus 70 equals 1/6 n minus 113. So t is 1/6 n minus 113 over 6 plus 70. There's 70, right? So t of n is 1/6 n plus 307 over 6. I think basically once you have that, the rest pretty much falls through. What is the slope of the graph? 1/6. So this, I guess, would be part A. M is 1/6. Okay. Delta y over delta x. So So delta Y is temperature, right? And delta N is the number of chirps. As T increases by 1 degree, the number of chirps per minute increases by 6. Okay. Please mute yourself. I do hear some background noise. Okay, and then C is just a plug-in. Save time for that. So crickets chirp at 150 per minute. So just plug in 150 for N. So just plug in 150 and figure it out from there in order for me to save some time. Okay, and I will go on. Okay, 1.3, yeah, raise it up again. Okay, then 1.3, let me see what I have here for 1.3. $37B as in boy. G circle F. Okay, so f of x is x plus 1 over x. G of x is x plus 1 over x plus 2. And G circle F means G of f of x. So I throw f of x here. Whoops. X plus 1 over x, which automatically tells me x cannot be 0. And now this crazy thing goes here and here. So x plus 1 over x plus 1 over x plus 1 over x plus 2. And to clean it up, I'll multiply the top and bottom by x, like that. So that gives me x squared plus 1 plus x, but I'm going to write it as x plus 1. And this is going to be x squared plus 2x plus 1. And yeah, I notice that this is actually x plus 1 squared. Okay, so for my domain, there's all real numbers except for 0 is not allowed and -1 is not allowed. So a set of all real numbers except for 0 and -1. Okay. And raise that up for you. And 37C was also asked for. 37C, F circle F. Okay, so it's F of x plus 1 over x. So it's going to be parentheses plus 1 over parentheses. And inside the parentheses is this mess. X plus 1 over x, x plus 1 over x. Now I cleaned it up. And for sure, x cannot be 0. So x plus 1 over x. How about multiply this one by x over x? Like that. So it's x over x squared plus 1. Whoops, that's plus, not equals. Yeah. Okay, so x cannot be 0. This can never be 0, right? X squared plus 1 is definitely positive. So my domain is all real numbers minus a set consisting of 0. You can stop with this. No need to combine this. So we'll just leave that alone. Okay, 53B, I believe, is what I saw. If I'm wrong, put it back in the chat. 53B, G of f of 0. So I start with f of 0. F is the red graph. F of 0 is 0. And I want g of 0. So g of 0 is here. That looks like it's 3. So 53b should be 3. Looks like. Okay. I think I've caught up with that. Okay, and then 1.5, number 3. Looks like was asked for. Okay. 1.5, number 3. Okay, then I would have caught up since the last chat. I do see some more in there. We'll see. What time is it? 15 minutes left or so. 1.5, number 3. Okay, just asking if it's a one-to-one function. So for one-to-one function, you look for any duplications in the y or f of x. Okay, so is any of the y coordinates, f of x, duplicated? The answer is yes. Looks like 2.0 shows up twice, right? So number 3 is not a one-to-one function. It is a function. 1x gives you only 1y, but for a one-to-one function, 1y can only have 1x before it. And that's not true for 3. Number 4 is a one-to-one function. None of the y values seem to be repeated. Okay. All right, so let's see, 1.53. Okay, so I think I've caught up since the last chat. Let me double check. If I miss you, put it again, put it in the chat again, or unmute yourself and ask again. Okay, let's see. Okay, 1.5, number 70. Let's see. Okay, a little bit about the unit circle, I guess. Okay. 1.570, 1.5, 37b, 4153b. Okay. And let's see, okay, thank you, Prasanna. So Prasanna, I'll let you take care of that one. Okay. And let's see how much time I have for the rest. Okay. So 1.5. So just my quickie idea about the unit circle from Trig. Okay. If you have an angle theta in standard position, which means this is 0, this is 90 degrees, pi over 2. This is 180, pi, 3 pi over 2, 2 pi. X comma y is the same as cosine theta, sine theta on a unit circle. So the cosine of theta, you're just asking for the x coordinate. Sine of theta, you're asking for the y coordinate. Okay. So for instance, what's the ordered pair right here? The ordered pair is 0, 1, right? Which means the sine of 90 degrees or sine of pi over 2, we're just asking what's the y coordinate? It's 1. Cosine of pi over 2, we're asking what's the x coordinate there? That's 0. Okay, I know that's real fast, but that's as much as I want to show you for that right now. Okay, 1.570. 1.570. Tangent of inverse sine of x. Oh yeah, one of these guys. Okay, so call this theta, which means I want to find tangent of theta. So theta is inverse sine of x, which means sine of theta is x over 1. Okay, theta, SOHCAHTOA, right? SOHCAHTOA. If you want to write SOHCAHTOA on your cheat sheet, you may. Okay, sine is what? Opposite over hypotenuse. So opposite over hypotenuse. Do your a squared plus b squared equals c squared. This is radical 1 minus x squared. Okay, we went over that, I believe. Okay, if not temporarily, call this y, and then do your Pythagorean theorem, right? X squared plus y squared equals 1, which means y equals square root of 1 minus x squared. Okay, so now we want tangent of theta, right? So tangent is TOA, opposite over adjacent. So that's x over radical 1 minus x squared. Okay, and again, I'll raise it up. So you can see that there. Okay. Okay, and let's see. I lost track of what else was asked for. So let's see. 37B. Combining a single log. Okay, log base 8 of 60. I know you can't see it, but I'm just writing it down first. Minus log base 8 of 3. Minus log base 8 of 5. Okay, combine it into a single log base 8. Okay, both of these have minuses. That means they go into the denominator. So 60 on top. If it said plus, I would multiply by 3. Since it's a minus, I divide by 3. And likewise, if there was a plus, I would multiply by 5 on the top. But since there's a minus, the 5 also goes in the bottom. Okay, so this is log base 8 of 60 over 15, which is 4. Okay, and then I'm going to unscramble it with x. Okay, unscramble it, base, exponent, result, 8 to the x power equals 4. Okay, so now what I want to do is make both of these the same base. A very convenient base would be 2. So base 2, that's 2 to the third power, right? To the x. And this is 2 squared. This is still 8, 2 cubed. That's still 4. And now if I have a power and another power, I multiply the powers. 2 to the 3x equals 2 squared. And now I use the property that I have an equation where the bases are the same. The exponents have to be the same, right? So 3x equals 2. X equals 2/3. So the answer is 2/3. Okay, and let's see. 41. 1/3 ln x plus 2 cubed plus 1/2 of this super long thing, ln x minus ln x squared plus 3x plus 2 squared. Okay. Now, I have a property that says that 3 can come down in front and multiply. But what's 3 times 1/3? 1. Just cross them out. And I'll distribute these two. So natural log of x plus 2 plus 1/2 ln x minus 1/2 ln x squared plus 3x plus 2 squared. Okay, these cancel out, distribute, distribute. And by the same logic as over here, whoops, I can cancel these out. The 2 comes down in front, so 1/2 times 2 is 1. So now I have natural log x plus 2 plus 1/2 ln x minus ln x squared plus 3x plus 2. Okay, and now the rest of the problem is kind of like that one. So single ln x plus 2, plus means times, I'll bring that upstairs, x to the 1/2, and minus means divide by x squared plus 3x plus 2. Okay, I'm going to factor this. X plus 2, x to the 1/2 means radical x. This factors into x plus 1, x plus 2, and very conveniently I can cancel here. So it looks like I'm left with ln of radical x over x plus 2 is the best final answer for that one. Okay. And let's see, 53b. ln x plus ln x minus 1 equals 1. All right, I multiply these two. Ln x times x minus 1 equals 1. How do I get rid of an ln? Exponentiate. So these cancel out. So I'll distribute x squared minus x equals e, right? So I'll take that upstairs. X squared minus x equals e. X squared minus x equals e. Subtract e, x squared minus x minus e equals 0. Quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. 4 times 1 times negative e all over 2 times 1. So 1 plus or minus radical 1 plus 4e divided by 2. Okay, I throw out the negative because this thing's bigger than 1. Okay, I mean, look at this. Square root of 1 is 1, right? If I add anything to it, it's going to be bigger than 1, which means if I go 1 minus this, I'm going to get a negative. We're not allowed to take ln of negatives. So my only solution is 1 plus radical 1 plus 4e all over 2. Okay, so that is that one. I think I've caught up, but if I miss you, put it in the chat again. Yeah, it looks like we're not going to do any new stuff. Okay, so you have successfully prevented me from going on to the next section, that's for sure. Okay, let me try to catch back up where we are. Okay, let me see if I can do something about 1.25. Let me put that in my notes if I have time. What do we have? About 5 minutes left, 6 minutes left? All right. Y is sine x over 1. Okay, so I forgot which problem I was doing. Okay, so I think if you're talking about here. All right, so back over here, let me cover all this stuff up. I think this is what you mean. Okay, so I called that theta. So ultimately, I'm trying to find tangent of theta. So theta is inverse sine of x. Okay, rewrite it without the negative 1, right? You don't like inverse sine. Sine's better. So I'm taking the sine of something. Am I taking the sine of x? No, that makes no sense. I'm taking inverse sine of x. So I can't be taking the sine of x. I must be taking the sine of something else. What else is there? Theta. So sine of theta is x. Okay. I choose to write it as x over 1 so I can do my triangle stuff. Okay, I think that's what you mean by that. And then since I know sine is opposite over hypotenuse, I make myself a little right triangle. Opposite is x, hypotenuse is 1. Do my Pythagorean theorem to get radical 1 minus x squared. And there you go with that. Okay. And let's see, I know something else just came in the chat, unless you want to catch that persona. But yeah, about 1.2 number 5, especially again. So we were dealing with 1.2 number 5. It was cosine x over 1 minus sine x, f of x. Okay, there's no trouble with the top, but the bottom is not allowed to be 0. Remember, right? You're never allowed to divide by 0. So I want to find out, when does this become 0? 1 minus sine x equals 0, or sine x equals 1. Okay. So where on a unit circle is the y coordinate 1? We'll just start off with the y coordinate being 1. That's right here, right? 0, 1. That's the only place. So what is that angle? 90 degrees, which in radians is pi over 2. But that's not the only such angle. I can go around 360, 2 pi, get it again. I can add another 2 pi and another. I can get as many as I want, but keep going around and around. And I can also go negative. Okay, so that's why we do this stuff. Theta is pi over 2 plus 2k pi, where k is an integer. You can say, what is all this about? Okay, if k is 0, it's just pi over 2, the one angle that I have. Okay, if k is 1, I'm adding 2 pi. Adding 2 pi means just go around 360 degrees. So, oh, I land here again. If I plug in k as 2, I got 4 pi. That's going around twice. Again, I land here. If I plug in 3 times 2 is 6. 6 pi is going around 3 times. So you're here, then you go 1, 2, 3. And you keep doing it. You can plug in 1,000,000. Then you're just going around 1,000,000 times. And you can put a negative. If I put a -1, okay, then that means I'm going back 360. And -2 is you're going back twice. And -1,000,000 means you're going back a -1,000,000 times. And so you get all the angles. Okay, so all of these have to be thrown out of the domain. So that's why the domain is all real numbers minus the set consisting of pi over 2 plus 2k pi, where k is an integer. Okay, let me quickly catch the chat. Okay, correct. Okay, 1.571. We have a few minutes left, and maybe that's about it. Let me see if I can squeeze that in. What was 1.571? Yeah, that was the one I gave you for your in class the other day, I think, right? 1.571, and that might have to be the last one. Okay, so same game, sine of inverse tangent of x. Okay, so I'm playing the same game as over here, sort of. Okay, so I'll call that theta. So ultimately, I'm trying to find sine of theta, right? So theta is inverse tangent of x. Okay, write it without the -1. Okay, am I taking the tangent of x? No, that doesn't make any sense. You're taking the inverse tangent of x. So it can't be the same as tangent of x. It must be taking the tangent of something else. Well, what else is there? There's only one thing else, theta. So tangent of theta is x. But since I'm going to do a triangle, and I'm going to do my SOHCAHTOA stuff, write it as x over 1. So theta. Okay, TOA, tangent is opposite over adjacent. So here's the opposite, here's the adjacent. I need to find a hypotenuse, I'll call it h. So a squared plus b squared equals c squared. X squared plus 1 squared equals h squared. Take the square root of both sides. So h is the square root of 1 plus x squared. 1 squared is 1. So h, hypotenuse, is radical 1 plus x squared, like that. You can see that. Now let me raise that up. Sorry, let me raise all of these up too. I don't remember how far back I got before I couldn't show you all this stuff. So let me give you this, and so on. Okay, so what are we trying to find? Sine of theta. So sine, SOHCAHTOA, sine is opposite over hypotenuse. So opposite is x, and the hypotenuse is radical whatever. Radical 1 plus x squared. And there we go. And I see we're just about out of time, folks, so that's all the time we have. Okay, so thank you, Prasanna. If you have a review session with Prasanna, you may ask him for stuff. Okay, so tomorrow, no questions and answers. We'll go straight to the test. I'm not going to call row the traditional way. Just think if we were taking a test on campus, I wouldn't call the row, right? I got plenty of time to, I have a whole hour to check who's here and who's not. So just shortly after 9 o'clock, I will send via Canvas announcements the exam, and just get started. Keep yourself muted, but show your face. I have to have your video on with the true background. And if you have any questions, send it through the chat. Okay, so that's about it, folks. So have a good day, and we'll see everybody tomorrow for the test, okay? All right, so bye, everybody.
All right, see ya.
See ya. Bye.
And then, hi, I'm just gonna go join your office hours.
Right. Yeah, I'll get right to you shortly. Sorry.
Okay, I'm just gonna go add the link, and then whenever you start
Yeah.
it.
Okay. All right. Jared, this is recorded. You should be able to get it, later today.
I have a question, Professor.
Yes, go ahead.
So I wasn't able to join the Zoom. It kept saying connecting for a while. I'd have to restart my computer, and it's. I think it worked at around 9:16ish.
That's fine. So yeah, just look at the video later. That's the reason why I record it. I get
Okay.
internet connection problems also, so don't worry about that.
Okay,
And
thank you.
for attendance, yeah, I'll mark you as here, so don't worry about that.
Okay, thank you.
All right, you're welcome.
I'll see you
Did you have a
tomorrow.
question?